Hello. Sorry, I'll be late. I'm just setting up the environment. Okay, how's the assignment? And let me have a poll for this one. One, two, three, four. We have 4%. Okay. Okay, great. It's not too late if you just get started. We still have plenty of time to do the assignment since the assignment is not very hard. But you need to take care of that because I think it's due next week, right? Next Friday. Maybe you need to spend like 2 hours per day since today. And today we may go through the receiver part. Do you have any question for your assignment yet? If you do, just post it. You can also share your screen. So I can put more time on that part. How to implement retransmission for SIG. Okay, let's have a quick look. Maybe we need to have a look of the specification at first. Give me a sec. Let me open it. What to do after sending reset packet? Just closing the connection be enough. Okay, let's have a check of it one by one. So the first one is the retransmission for SIG. Can you see my screen? On the specification. And so I think you already know how to send this thing in the sender side, right? Last week we have already covered this part. But what if we lost the same packet? So you can have a check of this diagram in here. The left hand side is the receiver, right hand side is the sender. And once the receiver have opened, then it will keep listening for the same from the sender and then send the acknowledgement. So you are mentioned in here, what if we lost the thing? So I think it is something in here get lost, right? So you think this one, we lost this one. Yeah. So in this case, at first we need to know what to do. If we lost the first thing packet, then we need to do the retransmission in here, right? But when to do the retransmission? because we did not hear any kind of acknowledgement from the receiver part. So we will have a timer. We will have a timer, let's say, once the first packet, we call it P1, okay? The first packet, we send it and as P1, the second one is P2. So when we send the first packet, P1, then we will have a timer. Sorry, I can't type. Timer for T1. For example, now the time is like 4. So we will put the time in here. Then let's say we will have a 2-second timer. Then so we can have a if clauses. Then in the code you can say, sorry, I have some trouble on typing. That's so weird. Okay, that's very strange. Yep. So in here you may have like you will have some code like RECV RECV from, right? And you also need to set the timeout. Timeout equal to 2. Timeout equal to 2. Do you have any idea how to set a timeout? It's not the thing like this. You need to use the socket.timeout, set timeout. Use that function. So it will stop waiting from there. Then if timeout, then we just send the packet again, and we need to have a counter for this. So if the second packet also get lost, then we need to send the third packet, P3. And if we have 3 packet loss, then we may need to do other thing according to the specification. We may need to close the sender. So in here, I just want to give you a sample code here, but I will not do the like everything in here. You can have a check. Let me share my screen for the sender side. So in the sender, this is the template code from last week. You can get this code in the GitHub link. So in the sender side, in the run, you can see we have an open and send. So maybe we can put the same here, or you can create a new function like, let's say, TCP establishment or something like that, or handshake function. So in here, let's say we do it in here, but before we open the file, we need to do the same, right? So we can say send sync packets. So what's the first thing? So we need to do something like self.socket dot send to, right? We need to send the same packet. So you need to add something in here. You need to construct the same packet in here. Add something in here. Then the next step, wait for the act for the same. So what should we do? Maybe you can put a function in here. Let's say self dot is same act. So you can say if, then we maybe not act, then we send it again, right? and you may need a counter. And then like if counter, so in here maybe not if, you need to use the while the same is not act, then you send it again and counter +1. And then you need to also have a if for the counter. If counter like larger than 3, then you need to reset or do something. So that's the like pseudocode for this part. And the isThing act is the hardest part in here, because as we can see here, you may have some trouble to receive the acknowledgement from the thing, right? Because we already have a listen function at here. It will handle all the incoming message, right? So this subthread already handle all the message from the receiver side. So we need to do something here to make sure we acknowledge the acknowledgement for the same packet. So in here, we need to make a judgment if incoming message is the same acknowledgement, right? Then we need to set the value in here. Let's say we can set self.same act equal to true. So this will be easier to handle the situation in here. So you need to put your own code in this part. So you need to make some judgment in here to recognize this same act. Okay. Then you can maybe just put here if while not same act. So this one is just a simple value, not a function. And of course, we need to put a timeout. And you can also have a function self the same timeout. Okay. And for this timer, you need to put the code in here. You will say, the timer for what is this thing will equal to this one. I recommend you to use the datetime.timestamp. So you use the timestamp, which is easier for the time calculation. So that's the basic logic in here. But you still need to do some coding in this part. It's not complete. And this one is also not complete. Is that okay? Or you have other questions? Timeout will give an exception, right? So use that to calculate RTT. Yes, you can definitely use that. You can do something like this. So should be something in here, right? Incoming message. You can say, you can have a setting here, like self.socket.set timeout. You can set like 2 seconds according to the value, right? So you need to read from the user input. And in here, this may trigger an exception here. So you need to use the try and except socket dot timeout exceptions. You need to figure out this one by yourself. You need to catch the exception in here. But this one is not correct. Okay. Would you send the reset packet when 4 packets have been sent as they include the initial packet? They don't send any response. Yes, I think so. According to the specification, we can have a double check. In here, we can reset. So as you can see here, that's the condition that we may need to have a reset. So if we send 3 same segment and there's no acknowledgement, right? Then we need to reset it. And the sender needs to move to the closed state. The sender moved to the closed state, right? So if you have no idea what is closed state, basically it's just close everything. Yes, you can have a double check of this paragraph. Basically you need to close the socket, right? You need to close everything you have opened. And maybe write a log. How are we allowed to create a new function within the class, or should they be out of the class? I think you can put it inside the class. You can just put in here PTP close, right? If you trigger the reset, then you can just simply run this PTP close. So you can see we do have some code inside the PTP close. In here we will set the value of isActive to false, which will close the listen function because we have a while loop in here. So if this value is false, then the listen function will reach the end and close it. So the subthread will be closed. And we will also print a message. But maybe here we also need to close the socket as well. So we will release the port. Then we can reuse it in the future. That's the PTP close, and you can add more things if you think it is necessary. Next question. Of course, you can also put it outside of the class, doesn't really matter. But I reckon it's better to put it inside the class because we want to manage the sockets inside the class as we initialize it inside the class, right? Inside the sender class, we put the sockets or other stuff inside the class. So if you put it outside the class, it will be a little bit hard to manage it. What is the purpose of listen function? So the listen function is basically listening from the receiver side. So all the incoming message from the receiver side will be in here. So in here, because we only want to use one receive from function, but of course you can put this code maybe in the initialize here. You can also put it in here. Like let's say when you start the socket, before you create the subthread, maybe you can like put it here to you can put maybe you can do something like this, like sing and synac. You can do the same and synac the handshake procedure in here. You can also do it in here, but actually we don't want to have lots of receive from in your function or in your program. Otherwise, it will cause a lot of trouble because you have no idea. Like what if like this receive from will receive any other kind of acknowledgement from this receiver side? It will very hard to manage it if you have a lot of receive from or send to function in your class, right? So I don't recommend you to do it in here, but you can do it. Like it will work, but it will be a little bit hard to manage your code in the future if you have lots of code in the program. So in here, I just want to make it clear that you just want to have one listen function, which will help you to receive all the incoming message, right? So we don't want to have other receive from in your program. This is the only one. So you will always know all the incoming message will come to here. So it will be easier to manage the program. And for as well as for the send to function, in here you will have only one send to function in this function, right? So it will be easier to manage the content you send to the sender side, receiver side. Oh, sorry, I can't see my screen in here. I'm sorry. Let me just make it clear again. So in here, we can see the listen function. We will have a receive from, right? So you can have a double check in your program. So you can just simply search receive from. Where is the receive from in your program? You can see here, I have only one receive from in the whole program, right? So every time if I want to make something about my incoming message, so I will always come to here and try to manage it here. If you have a lot of receive from in your program, it will be a little bit hard to manage the incoming message. So I recommend you to have only one or try to have less receive from function in your program. And the same as the send out, the send to function. You can also have a check how many send to function are there in your program. If you have more than one, then you may have some trouble in the future. Like you have no idea when did you send and where did you send this message, right? So that's the thing. Let me have a check of the was Python discussed in the lecture. Yes, we are using Python 3 right now. Which lecture did we go through the Python? I don't think we have any Python content in the lecture. When should the timer start on both sender and receiver? Understand that timer start after receiving. Is it right? I think you're right. So we can go to the page 7, page 6, 7 in here. You can see the log is in here. This one is the sender side log. You can see when we send the first same packet, then we will start the timer. You can see in here, the timer start from 0 when we send the first same packet. And for the receiver side, you can see when we receive the first same packet, then we start the timer. So they are not synchronized. Can you say that again, please? When should the timer start on the okay, so we are talking about the timer. So why the what is the 0 in here, right? And what is the another 0 in the sender side? So we are talking about how to write a log in here. Let me put in here and we go back to the page 7 and do the comparison. So you can see the timer start in the sender side. So the left hand side is the sender. This one, this one 0, which means when we send the same packet in the sender side, we will need to start the timer. But in the receiver side, which is the right hand side, we will set the timer when we receive the first same packet. Can you explain 3.4? 3.4. This one? The sender. The sender should this one. Yes. So any question? The sender should implement all the features mentioned in here. Mentioned here. Right. So it's pipeline manner. So we can send a lot of packets. Let me draw a diagram in here. So we draw a diagram, make it clear. Give me a sec. How to draw on this? Okay. Diagram. Left hand side, right hand side. The sender, receiver. So in this one, we need to know this part. What should we do? We need to have a pipeline manner, which means we will have a pipeline like this. We will be able to send lots of packets at the same time, right? P1, P2, P3 at the same time. And of course, we will get the response if we have no loss. Let's say 3 acknowledgements, ACK1, ACK2, ACK3. So this is the fourth section that we need to do. We need to send several packets according to the max window. So that's the 3.4. And we need to have a buffer to store all unacknowledged segments. Is that okay? So what if we have a packet like get lost? For example, the second one lost. So we will have no acknowledgement too. So what should we do in the receiver side? Can you give me your idea? Yes, last week when I said we need to pipeline, but in the beginning we do one by one. Yes, because at first we are talking about how to get started, but at the end we need to have some pipelining like this. But firstly, you don't need to worry about this one. If you have not done the like send and wait protocol, don't worry about this one first. Yes, it's pretty similar. It's not pretty hard to do this one. Isn't sending one by one pipeline very similar? Should we store P1 and P3 in the buffer and send back to ACK2 as we are waiting for that? Yes. So the first thing we need to do in here is reply ACK1, right? Because we get it. The second one, because we did not get it. And in here, we need to like reply. That's the question. 2 or 3? Because we have no packet 2. Then we need to reply the ACK, which one for the third packet. So this part didn't mention about that one. Is it 2 or 3? You can find it in the specification. So So in here, at first, you can just simply acknowledge the packet 3 and wait for the timer. So in this part, I'm not saying at the end of the program, right? So when you reach here, so I want you to do the task one by one. So when you come to the task 4, then you can just simply reply acknowledgement 3 and save that third packet in the buffer. And once we have all the packets, then then we can combine them together. But at the end, you need to have a fast retransmit in here, as you mentioned here. This one. So when you come to the task 7, you need to reply act 2. Is that okay? Can you use a dictionary as a buffer to store all received packets? Definitely. You can do this. Will you lose marks? I don't think so. Did we mention we need to have any kind of method to save the like packet we have received? I don't think so. So all you need to do is simply reply the acknowledgement number and then save in the buffer. You can use the dictionary. And if you are not sure about that, or you want to confirm this, you can post the question on the forum. And if we confirm in the forum, then you can like, you don't need to worry about it anymore. Yes, so in this task, we need to reply Act 2 instead of Act 3. That you're right. But like if you are at the beginning of the program, you can just simply reply Act 3. It doesn't really matter. But when you come to the end of the program part, you have to reply Act 2. Because we need to have the fast retransmit, right? We need to achieve this mechanism in your sender side. So we have to reply Act 2 to indicate we have packet loss in the second packet, for the second packet. And we can go further in this diagram because this one is already lost, right? Let me choose this one because we don't have this one in the middle because we get lost. And what's next is we will do something here because we have received the act 1 and act 3 or act 2, sorry. Then in here, we need to send which packet? We will send the packet 4 and packet 5, right? And in here, you also have a timer at this part. you will have a timer. Let's say the timer is this long. And it's not timeout yet. And if we have received the P4 and P5, what's next? So what's the acknowledgement for these two? So it's not timeout yet. P4, P5. So it's Act 2 and Act 2, right? Because we still have no packet 2. So in here we will trigger the fast retransmission. Then we will know we need to resend the packet 2. But this is in the scenario if the timer is long enough. Let's say the timer is this long, and we didn't reach the timeout of the packet 2. How can we use multi-threading? The document mentioned to use multi-threading in retransmission, but do not know how to proceed. We put this one away. May I know what's the page of that? Like we need to use multi-threading for retransmission. Okay, page 12. In here. Yeah, so at the end of the program, we need to do this, but it's not compulsory. It's suggested, right? What I think is to, let me think. Maybe you can put it in the listen thread, so you don't need to create a new thread. But of course, you can create a subthread, another subthread for sending the new packets. So what is your idea? Because I don't know what is your structure of your program. So did you do how did you do the timer? So where is your timer? Which function are you putting in the timer? So we have this function, right? And where is your timer? You have create separate function to send the packets. Yeah. For example, I use this function to send the packet. I use this one. You can see I I send it here. This one is the same, and this one is the same. But in here, we open the file and send the packet, right? Then we need to add the timer in here. So maybe we can create a dictionary, self.timer equal to this kind of timer. And in here, we can use sequence number and the time stamps like this, sequence number 2 time stamps and etc. We can have a timer like this. So maybe you can create a subthread. Let's say define, you can have a new function. Let's say, what's the name of it? Retransmit. Then you need to have a check of the timer. So check the timer of the packet. So you will have some pseudo-code like this. If packet is timeout, then we send read and the packet, and it's timeout or first as transmit. Then we resend the packet. You will have a like while not all packet act. Then if packet is timeout or retransmit triggered, then we resend the packet. You can have something like this in here. So you put a function in like this in here, and then you add it into the initialization of the program. You can run it in here. So self.retransmit, right? You can just create a thread like this. Then you start it. Retransmit thread. Is that okay for this part? So you just do a function like this, and you create a subthread and do the checking. You will have a while loop, right? While not all packet act. So you need to set a variable self or packet act equal to false. So this loop will go again and again until you change this value. So that's the basic idea of this one. This one is not very hard, right? So you just have a while loop and you do the judgment time by time. And if you trigger the timeout, you just simply check the timestamps of every packet. If timeout, then we just resend the packet, or we retransmit the packet. And what is the difference between task 6 and task 7? Sending back and storing. Come back to here. So which page? This one? Oh, sorry, I may miss some question as we have lots of chat posting. So Mesh, please remind me if I miss your question. Just post it again so I can have a check of it one by one. So let's try to answer this one first. If I miss your question, please post it again. I'm sorry, too much chat. I may miss some question. Okay, let's have a look of the difference between them. What is the difference between task 6 and 7? So for the task 6, we only need to have a single timer for the oldest one. You don't need to have a dictionary or a list for the timer. You need all you need to have is just a single timer for the oldest packet. This one is easier, but it's quite similar. So you can see it's for the oldest one, and only oldest should be transmitted. And we don't resend every segment. We just resend the oldest one. And in the 7, yeah, we need to like do the fast retransmit. Yeah, just like triple duplicate X. Then we just do the fast retransmit. Just one more stuff. So what is the question? Sending back to and storing received packet in the buffer is part of task 6. So in the task 7, you also need to do something like this. So in the task 7, what is the acknowledgement number in here? Is it 2 or 3? So what is your opinion? Yes, it's 2. You're right. For the task 6, it's also 2. This one does not really matter. So this one, we are talking about the timer. You will have a timeout. So we are talking about the timeout event. So you are not worrying too much about the acknowledgement number in here. You can reply X3. Does not really matter in here, right? Because we are talking about the timer. Timer is another stuff. You can see at the left-hand side, we set the timer very long. So in this case, we did not trigger the timer. So in the task 6, you don't need to have a timer. You don't need to have the fast retransmit, but you need to have it anyway, right? At the end of it, you need to have the like fast retransmit anyway. So don't worry about the acknowledgement number in here. So you just save everything in the buffer and reply Act 2 and forget about the Act 3 in here. So I just want to make it easier at first, but you need to come to here anyway. Yeah, so what will be the case 6 in here? Let me try to remove this one. So if we have a timer in here, then in this place, we need to resend the packet 2, right? Pay 2. Timeout. When we receive packet 1, reply should be act 2. I don't understand. When we receive packet 1, we should reply act 2. No, we should reply act 1. But the sequence number, so you are talking about sequence number, right? So we will follow the rules for the sequence number for the TCP. Yeah, so if you're talking about the sequence number, you're right. But we're talking about Act 1 because we know this one is the acknowledgement for the packet 1. For example, the packet 1, the sequence number equal to 1000 and data equal to, let's say, 100. So what will be the reply for the sequence number? Act 1. The ACK number equal to what? So this is a question for the midterm exam, right? The 1100. But we know this one is acknowledgement 1, right? ACK sequence number. It's the ACK number. Acknowledgement number. But like, don't worry too much about this part. This one is not the exam. So you need to just make the program knows that. Like this one is for the acknowledgement for the packet 1. We will not be very strict on this one. As long as your program is working. But in the log, you need to make it right. But in the program, you just make it work. We will be sending back ACK 110 until packet 2 was received. Yes, just like TCP. If you are not sure, you can also have a check like for this, for the log. And you can draw a diagram for the log and figure out how does this work. So we send 3 different data and we receive 2 acknowledgements, right? For these 2. So this one, 5522, what is the acknowledgement for these 3 data? Like which one is it is the acknowledgement for this one? Is it this one or this one? Or this one? So I want to know, what is this acknowledgement? Yes, the first one, you're right. So I think you got the idea. So this value equal to this one plus this one, right? This one, these 2 plus together and will be this one. So we will know this acknowledgement is this data packet. And this acknowledgement is for this data packet. And where is this one? We trigger a timeout here, right? You can see the time and you can see we did not get any response and the timeout is like 100 milliseconds. Then we resend it and we get the acknowledgement, then we close it. So you can draw a diagram for this one to make it clear. How long should we wait to send cumulative X? So why should we wait if this one is cumulative X? So what is the meaning of this? Like, are you talking about the fast retransmit? Maybe we create a new one. Here. How long should we wait to send them? Like we receive 4522 at first, you're right? 5522 seconds, right? But a single egg is sent for 5522. Yes. So let me draw the diagram for this log to make it clear. So this one is not about the fast retransmit. You can see the first packet is same. Oh, sorry, let's join here. The first packet is not about the same packet. the first stuff is the SYN and SYN-ACK, right? This one is the handshake. Send the SYN and ACK. And this one, we send 3 different data in a row. The data 1, 2, 3. So we call it P1, P2, P3. And the P3 lost. And this 2 is ACK. Is it correct? So ACK1, ACK2 in here. And in here, you can see we triggered a timeout event. Since here, timeout 100. And then we retransmit the P3. And then we ACK ACK3. So that's the log file, and we also have a fin and FIN-ACK. So don't worry about this too. That's the diagram. So you're talking about a single acknowledgement. So we don't need to send the duplicate acknowledgement in this case, right? As we don't have packet 4 or packet 5. So if we have packet 4 or packet 5, for example, we have a larger file, and in here we send packet 4 or packet 5, then we can reply ACK3 and ACK3, right? So we can reply ACK3 and ACK3 to indicate we do not have the packet 3 yet. But we don't have this case in the scenario. If we didn't receive the ACK for packet 2, but we received the ACK for packet 2, then the timeout should be set for packet 3, right? If we lost the ACK1, but we receive ACK2, then the timer set for the oldest ACK packet should be the time for packet 3. If we lost the acknowledgement 1, then we receive acknowledgement 2, then we can set for the I think you're right. So you're talking about another scenario, right? So if you're saying that the packet 1, the acknowledgement 1 is lost in here, you're talking about this one is lost, but we get this one, we get the second acknowledgement, then we can say that the receivers I already get the acknowledgement already get a packet 1. Yes, you can do the judgment like this. But make sure you always reply the like lowest number in the receiver side. So if you follow this rule, this will work. But if you always reply the acknowledgement number, for example, if we have packet 4 and 5, you reply ACK4 and ACK5, then the program will not work, right? But if you follow this rule, it will work. So that's the reason we ask you to do the like TCP stuff. So just follow the TCP rules. You can avoid this kind of acknowledgement lost. I assume the case where P1, P2, P3 is sent from the sender. The receiver only sent back for P2 and P3. In the sender side, we receive P2. Sender assume P1 is also received. Yes, you are correct. So from the receiver side, packet receive what can be buffer time so that receiver send only 2 packets. Yes, you are correct. If we follow the TCP rule, even we lost the acknowledgement 1, it doesn't really matter, as we have the acknowledgement 2, right? So we know even this packet is lost, even this acknowledgement is lost. We can still say packet 1 and packet 2 has arrived. So I would just delete this one. So we just follow the TCP rules. Are this edge case? Yes, kind of. So you can have a double check at the end of the test, at the end of the specification. So as we show you here, the marking policy. So make sure you test your program one by one with the test case. I think maybe this Friday, I will bring you some more test case, so we can have a discussion. Like beside these 2 test case, I will maybe add 2 more, so you can have a try with your own program. So you can have like discussion with me about this part. So I will try to add more like test case beside the section 9. But like for now, if you already finish your program, so do it one by one. The test 1, so you do it like this and see how, like what is the output of your program, and do the test 2. So we will test every single one in here. So make sure your program can work with this kind of scenario. For the long structure, all log inputs should start with send. For the send the log. Yes. So you're talking about the page 7. Start with this kind of stuff. Start with the handshake. Yes. Start with the same packet. SYNAC, or you can have a duplicate same, right? If the same packet get lost, then we may have duplicate same and put it in your log. Let's say you lost the first one, then the second one should be also the same packet, but the time is different, right? Let me check if I missed any kind of question from you. And remind me if I miss your question. For task 5, when it is transmitted by the sender, does the mean need to be in the header section? Task 5. Yes, it is a part of task 1. So I think this part we have already done it in last session, right? In the last session, we have done something like this. So we open the file, then we get a random sequence number, and we put it in the header. Then we attach the header with the content, and then we send it. So this part is not complete, as we only have the sequence number and the packet type. We still have more things in the header, right? We have 3 different things in the header, but the idea is the same. We just attach the header with the content and send it via the UDP socket in here. We send it in the single UDP socket. Yes, because last week we go through basically everything in here. Yeah, so this week I plan to maybe have a look of the receiver side. Like in here, the receiver design, we still have some task in the receiver side. Do you have any question in this area for the receiver side? But for the receiver side, it's quite easy, isn't it? All we need to do is just reply the acknowledgement and drop the packet. So any trouble with the dropping the packet? For example, you have no idea how to drop a packet. Or you don't know how to read the headers. But we go through this part last week as well. We know how to read the packet, right? For last week's session. Oh, you have no idea how to drop a packet. Okay, not a problem. Have a quick look of the receiver from last week then. Let me try to revert this one to the last week's version. Let me try to run it. Okay, it is working. The receiver, I run it with the parameters. This is the parameters, basically the same as we put it in the description. And I run the sender. Okay, some indent error, then fix it. Okay, so that's the last week version, and we have some error in here. Try and accept. Oh, let me try to fix this one at first. I should not have any this kind of stuff in here. So this one is the last week version. Okay. And have a timeout error here. Let me try to fix this one. So let me just put a try in here. If timeout, we just ignore it. Accept socket dot timeout. Then we just do nothing. Okay, so coming back to here, then should work. Let's try to run it. Okay, no exception right now, but make sure you do something here. Okay, if timeout, then what should we do? Oh, you should have no timeout at this part, but anyway, it's not the important stuff in here. Let me clear the thing. You can see we can open the file and then send different packets from last week code. And it will also print the timestamps. It's a little bit complicated in the output here, but we are focusing on the packet drop, how to drop a packet in here. So in here, we can see we can receive every single packet from the sender side. So what should we do to drop a packet in this part? How to drop a packet? So to drop a packet, there is nothing to do with the sender side. All we need to do is in the receiver side. So for the receiver side, what to do is to, firstly, you need to read the parameters for the user input for the FLP and RLP value. So FLP value will for the forward loss probability for the data, thing, and scene packets. So in the receiver side, for example, like this, if we set the FLP value, so if FLP value equal to 1, which means 100% drop the thing or data or thing packet. Is that okay? If FLP equal to 0.5, which means 50% drop the this packet. So firstly, you need to figure out like what is the meaning of FLP and what is SLP. Oh, sorry, RLP. RLP. If RLP equal to 0.5, then we will have 50% to drop the which packet? Acknowledgement packet, right? So there are two different stuff. And let's say if we set the FLP to 0.5 and RLP to 0.5, then in this case, we may drop some packets. So if FLP, if this triggered, then drop the incoming same packet. Okay, so we do not reply any acknowledgement. And if RLP triggered, what should we do? Yes, you're right. So do not send ACK. So we don't send ACK, which means the ACK drop. So it's all the receiver side stuff. So if the FLP is triggered, then what should we do in the code? In the code, you can see where did we receive the stuff, RECV from. So you can find the code in here, right? In this side. If the receiver, this is the only code that we can receive the message from the sender side. So what should we do? We need to add some code here. If FLP triggered, right? So if you need to do some random stuff, random do something larger than 0.5 or larger than the self.flp value, then we drop this packet, ignore it, okay? So this is the pseudo code in here. So try to figure this out by yourself. So what kind of function in random library should we use? And how to drop this packet or how to ignore it. So it's pretty simple. So this is the how to implement the FLP. And the next one is how to trigger the RLP value. So RLP is to do not send the acknowledgement, right? So we need to find out where did we send the acknowledgement. So it is another function send to, I reckon. We need to reply, right? So where did we send the acknowledgement? This is the acknowledgement in the receiver side. So before we send the packet, what should we do? So we need to have an if command. But if the RLP like if it's also random stuff, random like larger or smaller than the FLP. You need to figure this out by yourself. Is it larger or smaller than the RLP value? Then we don't send ACK, okay? And in here else, then we send the acknowledgement. So should add something like this. This is the FLP and RLP is like pretty simple and easy. But you need to just figure this out, like how does this work? Can you go through how to read the header? Or can you tell us how to make a buffer? To read the header, because I have already done it. You can see the template code. We send the packets and then we can read the headers in here, right? the sequence number equal to 8, and this is the header message. You can see this is 2 bytes. These two are for the sequence number, and these two are for the type of the packet. You can see the sequence number is 8, and it is data packet, right? So in the template code, we can already read the packet. So all you need to do, maybe just go through the code. Where can we read the header? I think it's in here in the receive from. ICV from. So you can see that's how we read the header. Read the header. That's basically how we read the header. Just have a look of the code, these two lines, and of course this part is how to read the headers. If you still have a question, maybe go through the session from last week. We have the recording for this part. We like written this part from 0. And of course, we have how to write the header in the sender side. So basically everything you need in the code. It's in here, header. So that's how we create a header in this part. So have a check of the code first. If you cannot understand it, go to the recording. And how to make a buffer. How to make a buffer, okay? So in the buffer, you need to put something in the receiver side. I cannot teach you how to do the code, but I will give you some general idea of how to make a header. Just propose a data structure. Like at first, you may have some like sing and nag. So for example, we can have a initialization in here. If we get the same packet, which means we are ready to get a like whole file, right? We need to get ready for the incoming file. Then in here, we can initialize a dictionary or any kind of stuff you want, like file buffer, or you can just call it buffer. You can put it as a dictionary. And how would be the buffer looks like? You can have a buffer. This is the proposal of the buffer, but you can have a totally different structure. It does not really matter. So it could be a sequence number as the key, and the value is the byte. Like this is the content of the file, something like this. And once you have several packets, you will have different packets, like sequence number 1, sequence number 2. This could be a buffer. Then you just put everything in your RAM. And once we have everything, then we save into the file, but we need to like order this one at first. As we may receive the sequence number because the order in the dictionary may get wrong. Like this is also a content of the file. The dictionary could be like this. It's not like in the correct order. You need to reorganize it, like according the sequence number. So once you get a packet, you can just put it in the buffer. And if, once you have all the packets, then you combine the buffer. But like if you have another data structure for the buffer, does not really matter. This is just a proposal for the buffer we can have, but you can use a like you can use the list, or you can use string. Does not really matter, as long as you can organize it. The only thing we need to care about this part is the order of it, because in the buffer you need to know which part is this content. Would you use the sequence number to order the unordered packets? Yes, because the sequence number is the easiest way to like reorganize the packet. It's just like the ID of the data. Okay, we still have 10 minutes. Any other questions? For the sing and thing, if we need to send reset, the sender will move to closed state after sending reset, or you still need to wait for the response from the receiver move to closed state. I need to have a check. If we need to send reset, so why should we send a reset if we want to close it? Nothing lost. Reset. Okay. Yeah, so because in the reset condition, we can see if we didn't get the packet for several times, then we reset it. So it could be in the thing scenario, but let's have a look of the thing right now to make it clear. And let's draw a diagram of how this one work of the thing. So if we transmit all the data we want to send, then we will send a thing segment. And it will wait for 2 timeouts. Then it will enter the closed status. So I have a question here. Do we need to send a ACK for this thing? It seems we do need to send the acknowledgement for the thing. Yeah, according to the log file, we need to we need to get the acknowledgement for the thing. But what if we lost the acknowledgement for the thing? Okay, so you can see here, it mentioned this kind of scenario. Yes, for the thing, we will have a longer timeout according to the diagram here. You can see for the receiver side, we need to wait for 2 times of maximum timeout. So wait for 2 timeout. And then we close. But it's not for the thing timeout. It's after the acknowledgement of the thing. Then we wait for 2 timeouts and close. You can see here. So imagine here, the receiver should remain time wait and then close. So 2 times of the like timeout time, then we close. But it's not for the thing, right? It's not for the acknowledgement. And the question you ask is in here. If we lost that acknowledgement for the thing, then we send another thing. And if we keep losing the acknowledgement for the thing, then we need to reset, send a reset and close. Reset means just close, I think. Yeah, you can have a check. Reset, what should we do with the reset? Yeah, reset is basically a close. Yeah, but for the reset, you also need to send a packet. Can you see that? So when you go to the reset part, you need to send a reset segment to the receiver side and then close. Do you suggest finishing all of the sender function, then going to receiver function for order of assignment? No. Do you know what is the reason? Because, for example, you want to do the sender at first. You do the task one by one. Then you will figure out, like, for example, you come to the session, you come to the task 7. You need to do a fast retransmit. Then, like, if you do not modify the sender side or the receiver side, how can you achieve the fast retransmit? Yeah, so sometimes you do need to change a little bit in the receiver side. But as you can see here, in the receiver side, we don't have much thing to modify. In the receiver side, it's pretty simple and straightforward. So we just basically receive the packets, and sometimes we drop it, and we still need a buffer for the retransmission. And that's basically everything. So don't worry too much about the receiver side. When you come to the task, then you should know what you need to do in the receiver side. Maybe draw a diagram. Is it feature after week 8 demo code? What do you mean by this? Yeah, that's true. I think it's not about the consultation video because you spend enough time on your assignment. So now you can finally understand it. Because at the beginning, I give you this template code, then you will feel, oh, it's so messed up because have lots of function and it will have lots of class, different functions inside and multi-threading stuff and logging, lots of unfamiliar library inside. So you will feel a little bit headache. So now you spend enough time on this part, then you finally get some idea of how to modify this kind of stuff. Yeah, so if you still feel like confusing right now, don't worry too much. Just spend more time on the assignment. And then, like for example, you don't need to watch all the recording or all the video I have posted. You just need to do the task. So if you haven't started yet and feel very dizzy of the assignment, I recommend you to start from here. For example, you haven't started yet, so then you can come to the specification, have a quick look of each page of it. You don't need to memorize everything. You just need to get a general idea. And you come to here, come to the end of the file. You will see how to get started. Where is that part? Assignment submission. In here. So you come to the page 12. Come to the section 6 if you haven't get started yet. So we have tips on getting started. So try to do your own program for this configuration. So this, I call it first configuration for our program. So try to follow the instruction here, write your own program. Or you can also modify the template code we gave you. Like you can do this task by yourself at the beginning. So once you achieve this part, then you spend some time on the like recording video. It will be easier for you to understand everything. So try to get started in here. And don't worry too much about the lecture notes, as all you need to know is the TCP and pipelining, right? Just have some general idea of what is TCP and what is the congestion control. Just get some general idea of that kind of stuff. You don't need to go through the lecture recording. It will help, but because we don't have much time from now, as we need to do the submission by the end of next week. So maybe you just need to have a quick look of the content of the concepts of TCP, but you don't need to know everything about the TCP. Just try to do the programming right now, right away. Yeah, I didn't really understand what you mean by first config and second config. Can we just start modifying week 8 template and start from 3.4? Definitely you can. But I'm just afraid that the code is too long, right? The code is very, very long. For me, it's very familiar because I write it from zero. But for you, like maybe you can retype it. So you do not copy and paste. You type the code line by line by yourself. So you get some insight. So or you can like spend 30 seconds for each line, or you can write some comments line by line, like this one is say the sender port into the class. You can do something like this to make you familiar with the code, because I write the code line by line, so I know what is this line and what is that line. But you don't know this one. So maybe you type the code by yourself, or you can write the comment line by line. So just like you understand which line is doing which kind of task. This will help you to get some idea of how to modify the demo code. Because in the week 8, we already write 124 rows, almost one, and 100 rows in here as well. So it's around 200 rows, 300 rows. So all you need to do is spend more time on the demo code. Or you can start from here. As I said, if you have no idea how to modify the demo code, then you come to here, how to get started. So follow this paragraph and try to write your own program. And so it's not saying that you have to use the demo code in here. You can basically delete everything and start from zero. You can write your own program. Is the help session finished? Yes, I will stay for 8 more minutes, as I waste 10 minutes at the beginning. How long do you think it will take? Maybe 4 days straight. I have no idea for how long it will take, but maybe I reckon like 20 hours. We still have 2 weeks, like 7, 8, and we have 11 days, right? At least 10 days. So 2 hours per day. Can we send you an email if you have any question? Yes, you can send me email, but like if you want the fast response, because we are getting a lot of email day by day. So if you want to get it fast, you can ask it on the forum. You can go to the forum and post it, and we are looking at the forum like every hour. Based on the log output, the sequence number increased by the data size once they receive and send back the packet with the update sequence number. The sequence number, so page 7. Are you talking about the sender side? You're talking about this value. Based on the log output, the sequence number increased by the data side once it received and sent back the packet with update sequence number. Actually, no. As you can see here, the sequence number is this one, right? 4522 and 5522 and 6522. So when did we change the sequence number? When we send the packets, we will change the sequence number. So, right? It's not about the acknowledgement. But of course, if we get the acknowledgement for this one, then we can send another one. It does affect, but the rule is different. So you may have some like misunderstanding on the TCP rules. maybe have a check of the lecture slides on like what is the rules of sequence number. Just imagine the sequence number is the ID of the packet. So the ID of this packet is 4522, right? So the data size is 1000. So in the future, if we get a acknowledgement number, which is 5522, which is the sum of these two, then we will know, oh, we get this packet acknowledged. But I think you are talking about how to update the sequence number. Is it? Need to go. No, okay. Thanks for coming. Have a nice day. And feel free to join the Friday session. And we will also have a help session at the end of the submission. So next week, we will also have some help session. Okay, see you soon. And for the sequence number, you need to know, like, why did we have different sequence number in here? You just imagine this one is the ID for the data for this packet. And the acknowledgement is helping us to figure out which packet is received by the receiver. And if we receive some acknowledgement, then we can start to send another packet. But here is timeout. It's not pipelining. Is that okay? I'm not sure, so we change the sequence number in the header as well. Yes, so every time you send the packet to the outside, you need to modify the sequence number. Okay, now I get some idea of your question. So you're asking about the code stuff, about the coding stuff. It's not the concept stuff. So you are saying that like when should we update the sequence number? Like I need to find it here. Like in here, I have a random number for each packet, right? You can see I send the sequence number. It's not in the correct order because every time I use a random number, this is not correct. So not correct. What should we do? We need to have a number. Let's say we start from sequence number 1. And when should we, how can we like update this sequence number? In here, I just want to give you some like idea of how to like do the header, but it's not to construct the sequence number. So maybe when you read the file, or maybe before you read the file, you need to know how much packet do we have, right? Maybe you can create a dictionary, sequence number dict in here. Let's say in this text file, we have 6 packets, right? Then you can have a sequence number like this one, file part 1. You can have a dictionary like this, and if this one data size equal to 1000, let's say 1000. So it will be 11001. This is the sequence number, file part 2. 12001 file part 3. So you can have something like this. You can read the file and put every single part into the dictionary with the sequence number. Then you can send it one by one. So you don't worry about how to update the sequence number. I know maybe you want to modify the sequence number in here, right? Every time, like it, for example, the sequence number in here, let's say just 10,000, 10,001. And after you send the packet, then you may need to sequence number, like add data size. You can do something like this. This will also work, but you may have some trouble at the end of the program, right? As we need to have pipelining and other stuff. You can do it in this way at first. You can just simply do some calculation. You can add some number based on the sequence number and send them one by one. If we don't have packet loss, this method will work. But finally, we'll come to something like this. Wouldn't the dictionary be trouble for pipelining? Definitely. So you cannot send the whole dictionary, right? So this dictionary is just for your sender side, help you to organize which file part, which packet is for this sequence number. Oh, you can also create. You can also create a file content equal to a dictionary, equal to a list. So it would be file packet 1, maybe just call it packet 1, and packet 2, and packet 3. It does not really matter. You can have a like dictionary or list, and you put the packet inside. So you construct the packet at first before you send it. And this may make it easier. So this packet will be like in bytes, right? This is the byte stuff. We will have some byte stuff in here, and with the content. This is the content, and this part is header, and plus the content in here. So the packets could be like this. So you can also use a dictionary or use a list. Okay, so we have to stop in here right now. If you still have any question, feel free to come to the Friday session. Okay, thank you so much, and see you soon.